Okay, so two particles collide, one of which was initially moving and the other initially at rest. Is it possible for both particles to be at rest after the collision? Give an example in which this happens. Explain why it can't happen. Or explain why it can't happen.
So let's say that this is momentum conserved. I'm assuming it is. Conservation of momentum. Same thing. 440. Okay, so here we have two particles, particle A and particle B. It's saying that particle A is moving, but particle B is not. And it wants to know if it's possible for them to collide and both to stop moving at the same time. In this case, your momentum is conserved. Okay? So what the momentum is your mass times velocity. And here, it has nothing. No momentum. What's the momentum on the other side of the collision?
We're gonna have the initial velocity, the final velocity minus the initial velocity, but it's gonna have the same mass
Okay.
for block A. And then so the momentum is going to be negative for block B because it's gonna be a 0 minus the final velocity.
And the magnitude of that is just this. It's whatever number that comes out to be, because that plus that is your total momentum, and total momentum get carried.
Total momentum gets carried?
Yeah, it's possible to change these around, like to change the masses. Like it's possible to change the velocities from a high number to a little number, or from 0 to a high number, or from a high number to 0. But then the total number, like the total momentum, is the same. Your momentum, what is it? It's a P?
P.
Mm-hmm.
Your momentum total is going to be the same here as it is here.
That's cool.
Why is that, sorry again?
It's conservation of energy, pretty much.
Okay.
How you can't create or destroy energy. You can't create or destroy momentum. You can just change it.
So
it's saying, is it possible for them both to stop?
Unless another force is acting on it, then no.
Mm-hmm. Because what's the momentum of something that's stopped?
0.
0. And that is not 0.
So it is impossible for both of them to stop upon collision because the mass times velocity plus the mass of 2 times velocity 2 has to be equal on both sides?
Yeah. Exactly. That's what it is. It's your total potential is equal to total potential. Not potential, momentum. It's probably one of the easiest equations you'll ever come up with is mv plus mv is equal to mv plus mv. There's just a lot of mv's and
is it possible for one particle to be at rest after the collision? Give an example in which this happens, or explain why it can't happen. For one of the particles?
yeah.
Hmm.
Let me give you an example. On the desk of every single professor, in the movies at least, there's this little doohickey. I don't know what it's called, but it's pretty cool. Had me captivated when I was a kid. But like 3 right there.
I knew exactly.
Oh, yeah.
I knew what you were drawing before you even drew it.
Awesome.
They have a massive pendulum in Washington, D.C. It's one of the coolest things you'll ever see.
Like that big?
Yeah.
Just-
It's huge.
So what
Is it
happens?
called an oscillator?
Yeah, yeah, it does
So,
oscillate.
like-
I think that could be the name. That seems
I don't know.
fancy enough. Anyway, what will happen?
Energy is, well, we haven't talked about energy yet. but
Momentum.
Momentum is transferred through.
Because this is going at a velocity right here, and it has a mass. This has a mass at the beginning and a velocity at the beginning. So then you do before and after shot. So that's your before and after. That means that your energy, your momentum, is transferred, making this one stop and this one go. Just as long as the total momentums do not change, you're fine. You can do it however you want.
So how would you explain that? It's possible because energy or momentum can be transferred.
In any way you want. Momentum can be transferred in many different ways as long as the total momentums equal each other. B for